Okay, here is a short tutorial about ionic bonding. Okay, so you can see all these nice pictures about bonding. Okay, how atoms join together. So first let's look at elements and compounds. Okay, if you remember, elements are atoms, okay, of one element. Okay, so this is an atom, an element, which is hydrogen. This is another element, which is oxygen. But now they are joined together to make a compound. And as you can see, it has two hydrogen atoms and one oxygen atom. Therefore, this is H2O. What elements are in it? Hydrogen and oxygen. Okay? And so, okay, sorry, this should be over here. The name of the compound is water. Okay? Now, let's look at another example. So this is called carbon dioxide. Okay? Now, di means is the prefix for two, and it's because there are two oxygen atoms. Okay? What are the elements in it? Carbon and oxygen. And what is the formula? CO2. Okay? So why do atoms form a bond? Okay, now let's look at group 1 and group 8 elements. Okay, so what is the difference between group 1 and group 8? If you look over here, group 1 atoms have one electron in the outer shell, so it's very unstable. For example, this first shell can take two electrons, but there's only one. The second shell can take 8 electrons, but as you can see, it only has one. The third shell can take 8 electrons, but you can see it only has one. So this and this missing many electrons, 7. So it just wants to get rid of that extra electron so that it can become stable. Okay? Group 8, on the other hand, remember what we said? The first shell can take 2. And look at helium. It has 2. The next shell can accommodate up to 8. Now look at neon. It has 8 electrons in its outer shell. And argon also has 8 electrons on its outer shell. So the biggest difference is that group 1 metals are very unstable and therefore they react. Okay? While group 7, their outer shells are full, so they don't need to react because they are complete. This one is missing a lot of electrons. Okay, so they just want to get rid of that extra electron. Okay, so what is the aspirational goal of group 1 elements? As we said, their aspirational goal is to be stable like group 8 elements. They want to have a full outer shell. So the only way they can do that is to get rid of that extra. Okay? For example, sodium is a group 1 metal. Okay? And we know it's group 1 because it has one electron in its outer shell. Okay? Chlorine is a group 7 metal. Sorry, not metal, gas, non-metal. Okay? So sodium is a metal from group 1, while chlorine is a non-metal, which is a gas from group 7. So that means it has 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell. So we know that the third shell can take a total of 8 electrons. Okay? And there's only one. So sodium needs 7 electrons. That's too much. Okay? It would rather just give away that extra electron. While chlorine, okay, remember, can take 8 in the third shell. It already has 7. And chlorine only needs how many more? Chlorine only needs one more. Only needs one more. One more electron to be complete. Okay, to have a full outer shell. So what happens? It wants to get that extra electron. So it says, come to me, extra electron, and we will both be stable. Because you will get rid of that annoying extra electron, and I will use it so that I can have a full outer shell. So that is exactly what happens. Okay? The extra electron is given to chlorine. So now chlorine is happy with 8 electrons in its outer shell, and sodium is happy because now it has 8 electrons in the second shell because it got rid of that extra electron. Okay? And because of that, they are now both ions. Okay? In other words, ionic bonding happened because first, it was between a metal and a non-metal. Second, remember in the beginning we say that every atom has an overall charge of 0. Okay? But with ionic bonding, remember, sodium gave away its electron to chlorine. So now it has a positive charge because there are now more protons than electrons. While chlorine has a negative charge because now, since it took the electron from sodium, it now has an extra electron. So there are more electrons than protons. That's why it has a negative charge. So an ion is a charged particle because now, instead of the protons being equal to the electrons, in sodium's case, there are now more protons than electrons, and in chlorine's case, there are now more electrons than protons. Okay? And now the compound is called sodium chloride, which is table salt. Okay? Now, sodium has now become a cation. A cation is a positive ion. Okay? Now, why did it become positive? Remember, the atomic number of sodium is 11. Okay? So that means it has 11 protons and 11 neutrons. However, sodium gave its outer shell electron to chlorine. So 11 minus 1, there are now 10 electrons. So that means there's a greater, the number of protons is greater than the number of electrons. And since the protons is a positive charge, that is why sodium has a positive charge. Okay? Now, chlorine is an anion, which is a negative ion. Why? Remember, chlorine has an atomic number of 17. So that means there are 17 protons and 17 electrons. Oops, sorry. And 17 electrons. Okay? But look what happened here. It took one electron from sodium. So now it has 18 electrons. The number of electrons is greater than the number of protons. And since electrons have a negative charge, chlorine is now a negative ion called an anion. Okay? So, what is the overall charge of sodium chloride? Since sodium became a positive ion or a cation and chlorine became a negative ion or an anion, okay? So let's look at this one. Sodium gave away one of its electrons. Okay, so that's why it has a charge of 1 plus, because it has one extra proton. While chlorine now has one extra electron. That's why its charge is 1 negative. Okay? So let's think about math. You have positive 1 and negative 1. So positive 1, negative 1 equals 0. So that means sodium chloride, even though one is a cation, the other one is an anion, positive and negatively charged, it will still have an overall charge of 0, because the positive charge of 1 plus and the negative charge of 1 minus, 1 plus minus 1 will still give you an overall charge of 0. Okay? Because 1 plus 1 minus equals 0. Okay? So what exactly is ionic bonding? Okay, so let's look at the difference between ionic and covalent bonding. Ionic bonding happens between a metal and a non-metal, like sodium, metal, chlorine, non-metal. While covalent bonding happens between nonmetals like hydrogen and chlorine. Put together, they make hydrogen chloride or hydrochloric acid. Okay? What else should we know? Ionic bonding, okay, gives the metal gives their electrons to the nonmetal, like what happened with sodium and chlorine. Sodium had that extra electron and it just gave it to chlorine. Okay, because of this, one became a cation, which was the sodium, and the other one became an anion. Okay, so covalent on the other hand is sharing of electrons. Okay, so for example, in hydrochloric acid, HCl, okay, hydrogen has one electron, chlorine has 7. So chlorine needs one more to be complete. But if hydrogen gives up its electron, then what will happen to hydrogen? So it cannot happen. So what's happening is they are sharing that electron, so that hydrogen will have 2 in the outer shell and chlorine will have 7. Okay? So that is the difference between ionic and covalent. So let's go back to the ionic bonding. Okay? So this table will tell you how many electrons are given away or lost, and how many are gained. Okay, so this is the group number, and this is the charge of the ions in that group. Okay, so let's look at group 1. Group 1 has 1 electron in the outer shell. Therefore, it can give away or lose 1 electron. And when that happens, there will be one more proton than electron. That's why the charge is 1 plus. Okay? And some examples in group 1, of course, you have lithium. So that would be 1 plus. If you notice, if it's just plus, that means 1 plus. Okay? So lithium would be 1 plus. What's next? Sodium will be 1 plus. Next is potassium will be 1 plus, and so on. That means all the elements in group 1 will be 1 plus. Okay? And then let's look at chlorine. Chlorine is over here. Group 7. Group 7 already has 7 electrons in the outer shell. So it wants to take an electron. So that means if it takes an electron, it will have one more electron than proton. That's why it's 1 negative. So all the elements in group 7 is 1 negative. Okay? Now, all the elements in group 2 would be 2 positive because it can give away 2 electrons, okay? So let's look at this example. It says, why does magnesium bond with 2 chlorine atoms? Okay? So let's look at the table. Magnesium has, okay, atomic number of 12. So that means the first shell can take 2, the second shell 8, and the last shell 2 again. So that means it's a group 2 metal. Okay, let's check. So group 2, that means it has 2 electrons in the outer shell, and that means it can give away. There you go, magnesium. So the number of magnesium is 2 plus. That means it can bond and gain 2 electrons. It wants 2 electrons. Now look at chlorine. Chlorine can only gain 1 because it has 7 in its outer shell. So it can only take 1. But magnesium can give 2. So what's going to happen? If magnesium can give 2, then that means it needs to bond with 2 chlorine atoms, okay? Because chlorine has 2, 8, and 7. And then the other chlorine has 2, 8, and 7. So what's happening here? One of these will go here, and the other one will go to the other chlorine atom. That's why magnesium chloride is 1 magnesium atom bonds with 2 chlorine atoms. Okay, so which is the cation? The cation would be magnesium. Since it lost 2 electrons, there are now 2 extra protons, giving it a charge of 2 plus. Okay? While chlorine is the anion. So each chlorine atom has gained 1 more electron. So that means there's 1 extra electron than protons. That's why it's an anion with a charge of 1 negative. Okay? So if we look at this, you will have magnesium, which is 2 plus, and chlorine 2 gives you 2 negative. So the overall charge will still be 0. Okay? So let's look at this table. We have sodium. What is the charge of sodium? Okay, so let's look at its group 1 over here. So it is positive, okay? 1 positive. While sulfur is 2 negative. So what does that mean? How many sulfur atoms will bond with the sodium atom? So sulfur needs to get 2 electrons, but sodium can only give out 1. It just wants to get rid of 1. So what does that mean? So we have sodium, okay, 2, 8, 1. While sulfur, okay, which has 2, 8, and it needs to take 2, so 16. Okay? So this sulfur needs 2 electrons to be complete. But sodium only wants to give 1 electron. So what will happen? We need another sodium. Okay? So this one goes over here. So what is the formula? Sodium, we need 2 sodium to bond with 1 sulfur atom. So you have sodium sulfide. And if you look here, see, Na is 1 plus, sulfur is 2 minus. So in order to make them balanced, you need another sodium atom. Okay? another sodium atom to bond with one sulfur atom. So this is the balanced equation. Okay? And that is how to use the table. Last example, gallium oxide. Now look at this one. Gallium is over here. Okay? Gallium is 3 plus and oxygen is 2 minus. Okay? So, how are we going to balance this equation? Pause the video and think about it. Okay, so let's look at this one. Gallium. Gallium can give away 3 electrons, while oxygen can only take 2. Okay? So let's look at this way. So gallium would have 3 electrons in its outer shell, while oxygen, how many electrons in its outer shell? It's in group 6. So it has 6. So it only needs 2 to be complete, right? So let's look at this one. So gallium gives 2. Then there's an extra one. What will that extra electron do? So it wants to look for another oxygen. So the third electron goes here. Okay? But then it's not complete because oxygen needs 2. So what do? We give another gallium. So it can give away 3. There you go. So there goes the other one. So the 2 oxygen atoms are happy. But gallium is not happy because it has 3 electrons to give. This one only gave 1. So what's going to happen to the other 2 electrons? No problem. Let's make them bond with another oxygen atom. Okay? So now the last 2 goes to the third oxygen atom. Okay? So what happened? Gallium has 3 electrons to give. The first oxygen atom takes 2. So the extra one needs to bond with another oxygen atom. But then this one needs another one. So we provide another gallium atom, and the next one comes from that one. But then there will be 2 extra. So it will bond again with another oxygen atom. Okay? So in other words, 2 gallium atoms bonded with 3 oxygen atoms to make gallium oxide, which is written as gallium Ga2 oxygen 3. What this means is that 2 atoms of gallium bonded with 3 atoms of oxygen. Why? Because that way, okay, 2 of the electrons go to 1 oxygen atom. The third electron and the first electron of the other gallium atom bond with another oxygen atom, and the last 2 electrons of the second gallium atom bond with the third oxygen atom.